Hey, today I have the pleasure to host Cody Davis. Hi, Cody.
Hi, how's it going?
All good, all good. Can you please introduce yourself to the community?
Sure. So my name is Cody. I've been an SA at Databricks for almost 4 years now. I've been leading our Databricks SQL data warehousing SME group. In doing that, I've worked with customers throughout the company, helping them build tools and do data warehousing on the Lakehouse with Databricks.
Amazing. And for people who doesn't know what SME means subject matter expert. And Cody is part of a group of people, and they are behind an awesome blog that I will add the link in the description of the recording. But you can see many articles about how you can improve the performance and a lot of like very technical things. And one of the articles I saw recently was about the DBSQL Warehouse Advisor dashboard. Can you tell us more about this dashboard, Cody? Like, what was the reason of building it, and then how I can leverage it?
Yeah, so I built this Warehouse Advisor dashboard because data warehousing is complex, and managing data warehouses and observing data warehouses are hard enough. They're even harder on the Lakehouse. So I built a dashboard that helps customers measure the performance of their entire warehouse portfolio out of the box. So they don't have to guess on what performance is, what TCO looks like, as well as be able to quickly dissect problems and find issues so they don't have to spend a lot of time and energy looking for needles in the haystack.
Yeah. And what I love the most about this dashboard is that you did keep up with all the latest innovations in AIBI dashboards. You added the tabs, like whenever you release a new feature, and so which means this dashboard is not a legacy. You keep adding features every time, and like a lot of every time we keep pushing stuff.
Absolutely, yeah. I always try to stay up to date with AIBI dashboards because I think Databricks has taken that product, especially a really long way, really, really fast. So I definitely consider myself a power user of the dashboard. I can even show some of you guys what some of my favorite features are, like cascading filters, drill throughs, as well as custom formatting and tables. There's tons of stuff I love doing. But yeah, it's really becoming a powerhouse of a lightweight BI tool.
Yeah, and can you show us like an example of this warehousing advisor dashboard and
Sure.
walk us how we can maybe start using it to optimize or get the most of the platform?
Yeah, absolutely. I'm happy to walk through what the dashboard looks like, but more importantly, I'm happy to walk through also how to apply it and use it. So let me know if you can see my screen.
Yes.
Great. So this is the Warehouse Advisor dashboard. So deploying this dashboard is really, really simple. All you have to do is go to the Git repo and blog linked that we can link here in the chat somewhere. Then once you deploy it, there's really two steps. You run a SQL script. That SQL script creates a materialized view or table data model that does all this analytics for you. Measures query performance, builds the data model so you don't have to calculate things manually yourself. And if you use the materialized view version, it automatically schedules that model to stay up to date without you having to think about it at all. So once you do that, it takes less than a couple minutes to run. And then all you have to do is import the JSON dashboard template, and then you're off to the races. So there's no manual coding. You don't have to dig through the queries. If you don't want to understand like all the nuances of the dashboard, you definitely don't have to. You should be able to get value out of this and start using it within 5 minutes of deploying it. So once you do that, you'll be taken to a README screen, which just describes the actual Warehouse Advisor dashboard itself. Zoom in a little bit here. And then once you're here, the dashboard describes 4 different tabs. Tab number 1 is the warehouse usage summary. All this is doing is taking a subset of the broader cost dashboard and zooming into specifically DBSQL warehouses. So it allows you to trend overall costs of your DBSQL warehouses over time, break out those costs by the type of warehouse that it is, the workspace, any tag combinations you have on your warehouse, as well as being able to choose specific warehouses and see edits to those warehouses over time. So if you've had a warehouse that's running in production for a long time and someone makes a config change, this allows you to highlight and very, very quickly discover and identify any of those changes, what was made, what changed, who made the change. So very critical to be able to do. And then these detailed warehouse visuals just show the proportion of total cost of your warehouse spend that you have selected over time. So here we can see, let's see, our shared endpoint represents about 12% of our total warehouse costs in this given day, and that's fluctuated by quite a bit over time here. So that's really it. This is a very, very simple section just to give you a quick one-stop shop temperature check of all of your warehouses from a cost perspective. Any questions here so far? I really want to jump into the actual performance section because this is usually where customers have the most questions because there's a lot of metrics that go with managing warehouse performance.
And I think just something to remind folks, you need to make sure that you have the latest tables in system tables because all the data that this dashboard is getting are from those tables. So you need to make sure to have them all enabled to benefit from this dashboard.
So this dashboard uses the billing, query history, warehouse events, as well as the warehouse's system tables. So you need at least those to run this dashboard. So that's a good call out. All right. So the next tab here really shows how the warehouse scales. So as you size a warehouse, especially if you have high concurrency workloads, this shows you how much the warehouse is spent doing any work. Like, are people running lots of queries in the warehouse? Is it sitting idle a lot of the time? But more importantly, how it scales for concurrency over time. So how much time it spends scaled up to 0, 1, 2, 3, 4 n number of warehouses. This helps you get a bottoms-up understanding of what the concurrency workload shape looks like. It is a very, very common mistake to overestimate the concurrency. So I've seen this happen, customers over and over again say, well, it scales between 0 and 4 warehouses. So let's say on average, we're paying for two concurrent warehouse scaling, over time. That is a vast overestimation because of this shape. It's actually spending most of its time not even on at all. So this really helps you show exactly that. But even more, show you what that looks like over time. So at a given daily or hourly grain, you can see the actual peak time periods in which the warehouse is scaling a little bit more than usual. So if this particular day, and you can even sort by hour as well, is particularly high stress or high intensity for the warehouse, you can see what that looks like and adjust your query workloads or warehouse configurations accordingly. So the main section here is this performance advisor section. So this is the tab that I spend most with most customers on figuring out how to understand all these metrics to actually get to recommendations for how to make your warehouse more cost effective and more performant. So we'll go through some of these, but it really just boils down to a couple things. In DBSQL warehouses, you only have so many knobs, and you really don't want to have to, Databricks, don't want you to have to tune a bunch of knobs. So we want this to be as simple as possible for you. That being said, if you're running serious workloads in production on these warehouses, you still want some semblance of control and visibility and observability into what performance looks like, knobs or not. So here are the metrics that are most commonly used to help decide, is my warehouse the right size? Is it hitting the required performance that I even want? And is it doing that in the most cost-effective way possible? Those are the primary questions that we have to answer. And I like to start always with the SLA. What is the query runtime and throughput that you need to justify and successfully run your workloads? And then everything else in this dashboard is based on minimizing costs for that given SLA. So that's the optimization problem that we're solving here in this dashboard. Any questions or thoughts so far? Then we can kind of jump into the metrics themselves and show you how I kind of relate them to find recommendations.
It's very clear so far.
Awesome. So here we can see the query runtime. So this is our SLA. This is expressed in P95, P99, even P100, which is technically the max query runtime. These three metrics here get us an idea for the shape of our runtime distribution. So let's assume that 16 seconds, our P95, is too long. 16 seconds is too long. We need it to be under 10 seconds. What do I do? How do I make it go faster? What specifically do I need to change? And how do I change things without, wasting a bunch of money? So that's what we'll figure out here. Always start with the SLA, minimize cost and warehouse size based on that SLA. That's the problem we're solving. From here, you have two knobs. You can control the t-shirt size of the warehouse, and you can control the concurrency. And the concurrency simply means what are the number of parallel clusters that are running in the warehouse to increase query throughput. That's all that means. So first is warehouse size. Over on the right-hand side here, you can see metrics for data intensity and data throughput, as well as data spill rates. So data throughput, data intensity is just a fancy term for how much data are my queries reading and writing on average, and what are the sort of limits of those. So what's my P99 of my data intensity? So this shows the average query reads about 0.10 gigabytes, which is very low. 100 megabytes, no problem at all. You don't even need, probably a 2 extra small warehouse to do something like that. Our most data intensive queries, our P99 in data intensity is about 1 gig. So these are very tiny queries. These are not data intensive. We're not reading and writing a bunch of data. We almost never spill data to disk, which is what this metric means here. And what that means is when you spill to disk, that means the cluster doesn't have enough memory to process the query for a multitude of reasons. But in general, not always, it generally means making the warehouse bigger can help that. So when this spill frequency is really low, it means the warehouse is properly sized or even too big, oversized. You don't need that big of a warehouse. So let's say our warehouse is a medium. So it doesn't show it here because we can actually select many warehouses at once to measure performance. But if we pick on one warehouse at a time, we can go back to the usage summary and scaling patterns for that warehouse and see, okay, this is a medium scaled 1 to 4 clusters during the time period we're analyzing. How can we make the decision to adjust accordingly from there? So we have data intensity. We see that it's really, really low. Which means, directionally, we need a very small warehouse to accomplish this. So warehouse sizing is a nuanced exercise, but there are very, very basic sort of directional templates you can start with. In general, we recommend starting with the medium. Medium is great for processing tens of gigabytes to hundreds of gigabytes in a really strong, in a really strong manner. If you have more than hundreds of gigabytes you're reading in a given query, slowly stepping up into the large space. And then if you have terabytes or petabytes, extra large to extra large plus. But one thing customers do pretty often is they start too big. A large warehouse compared to a medium is not going to get you much more throughput. And if your queries are small, it's actually not going to get you better performance because you're not even taking up the size of the warehouse. So it's important to make the warehouse smaller when queries are small, just as much as it's important to make the warehouse bigger when queries need more power to process. But it all goes back to SLA. So if the warehouse is spilling data everywhere, writing everything to disk, it's too small, but you're hitting your SLAs, there's no point in increasing it, usually. So that's the first half of the coin. We've discovered maybe a small, even a 2 extra small warehouse would be plenty for these types of workloads that are not reading that much data. Our query throughput, our queries per second, queries per minute is not super high on average. So it's not a very data intensive warehouse. However, there do seem to be spikes in concurrency. And so this is the more nuanced, interesting problem. Sorry, was there a question? I want to make sure
No.
Cool. So this is the more nuanced, interesting part of the problem where concurrency usually is not static. It's very spiky. And that's what serverless is all about, optimizing for elastically scaling for those types of spiky workloads. So we have these metrics here to measure what that sort of concurrency looks like and the distribution of concurrency intensity. So all that means is we have our P95 of peak queued as well as our P50. Same thing for peak running. So this is the P95 of our most intensive parallel running queries. So our most intensive parallel running queries, in our more intense states, we're running 10 queries at a time. In our most intense states, we are queuing 14 queries at a time. Directionally, 10 plus 14, 25-ish queries that we have to deal with concurrently at its peak. So these are all, sort of directional in nature. It's not an exact science, but it does help give you some decisions directly. It's not enough to be able to say, okay, a warehouse can process 10 or 20 or 30 queries at once. So if we're under 20, then don't scale up. If we're over 20, then scale up. each query has different CPU and processing needs. So when users and customers ask me like, how many concurrent warehouses should I use? Should I just, finger in the wind, like one warehouse per 10 concurrent queries? The answer is no, don't really do that. You can do that as a starting point, but the number of parallel queries actually is increased quite a bit. It can be like well over 20 sometimes now, or even higher than that per cluster. It can also be less if the queries are really, really intensive. So the Databricks SQL AI workload management algorithm figures out how to distribute the work accordingly relative to the query intensity for each. So all that to say, go back to the SLA. If your concurrency is, let's say, scale 0 to 2 concurrent warehouses, and the concurrency isn't that high, but you're not hitting your SLA, it's possible you have some bottlenecks or 1 or 2 expensive queries that we can find easily in this dashboard, and that increasing concurrency might help. How do we know it might help? Well, it doesn't just matter how many queries are queued, but it also matters how much time is wasted of the query's life sitting in the queue. So that's this percent time in queue. This is sort of the most awkward one to understand, but in my opinion, from my experience, the most helpful to help me make decisions. So this shows the P50 and P95 of the percentage of time wasted in the queue of a query's lifespan. So for example, if a query spends 10 seconds in the queue, but takes 10 minutes to run, that's a very low proportion of its life it's spending waiting around doing nothing. That's not bad. But if a query takes 10 seconds sitting in the queue and runs in 1 second, it wasted over 90% of its life doing nothing, sitting and waiting around. And that adds, pressure, backlog pressure. This 0.89 means that 5% of your queries actually spend a good majority of their life in the queue. So there's probably some spiky workloads that come on suddenly during the day, and we need a bit more concurrency for those specific time periods. But the workload's pretty elastic because on average, it's actually not that high concurrency. Our throughput's not very high, so it doesn't stay scaled up very high. So scaling back down to 0 should be very, very common here. These are kind of how we use those metrics together in tandem. So overall, if I'm running a medium warehouse scaled 1 to 2 clusters and I need to get below my SLA of 10 seconds, I might actually choose a small warehouse scaled 1 to 3 clusters and see if that gets me increased query throughput and decreased queuing time in my future subsequent workloads. The cool thing about this dashboard is you can run those load tests and compare the results before and after, and just take snapshots of these dashboards to show. So this is actually how we run like a lot of our evaluations for sizing workloads, for figuring out what the best configuration is. So that's a high level description of the metrics. Not all the dashboard is built around those metrics. So the rest of the dashboard just gets to show you more intelligence around what's going on in the warehouse. So this shows where your query is coming from. You can dynamically choose the dimension that you want to see. So if you want to look at, your queries by statement type, your query volumes by warehouse, workspace, even your query failure rates by execution status, you can do that. You can also zoom in or out of your time grain. Sorry, was there a question?
No, so just aggregation. Yeah, it's super interesting to understand how it evolved within a day, hour, month, or year.
Yep. And this is one of my favorite features of the AIBI dashboards is because they're SQL native. There's not this proprietary custom like DAX-like language that you have to learn. You can use and make these dynamic visuals just in SQL. So with SQL plus these dashboard parameters, you can make the dashboards really, really flexible and dynamic that way. So I put these all over my dashboards because it makes the number of visuals a user has to digest a little bit less. As you see, that's important in this dashboard because there's a lot of visuals. Makes it a little simpler to the eye. So we can see our query volumes. We can trend them over time, sort of see when the spiky days or hours or months may be. But we can also trend our runtime SLAs over time and break it out by warehouse. So we can see that this warehouse is a bit more data intensive and has higher P99s and P95s in this shared warehouse. Different workloads are running on it. And this type of view can be trended over time as well. This is important to see for multiple warehouses because it is a very common use case for users and customers to have a fleet of warehouses that drive a specific workload in production. This can be a data app. this can be anything, that are powered by many warehouses behind the scenes. And this lets you gauge the performance of all of them in one place. So that's really, really helpful to sort of understand where your sort of strong and weak spots are in your fleet of warehouses here. So going to the details, we did discuss like sort of peak queued and peak running. This describes those distributions from the summary charts just in a more visual way. So you can sort of see the relationship between the median peak queued count and the median peak running count, as well as the P100, the maximum queued. So at its max, we queued 82 queries. So as we suspected, there's a huge spike all of a sudden that happens that we need to scale up elastically for to decrease our runtime, but the average query throughput is not high, so these don't stay around for long. That's good to see. Same thing for this percent queue time. So we can see that the median queue time is 0. Queries, the majority of the queries don't waste any time in the queue, maybe a very little bit, but the long tail, 5% of our queries waste 90+% of their life in the queue. That's the part we want to solve for, and that's probably because of these big giant spikes. So if we don't have enough concurrency for 82 queries, it's going to take, a couple seconds for those other warehouses to spin up and, run those and burn down through the queue. So increasing concurrency can help burn that down faster.
By increasing concurrency, you need to add more clusters and not to increase the size of the SQL warehouse.
Yes. Yeah. So increasing the t-shirt size will not really help you on increasing your your queue burn down rate. So that's a very common mistake I see, is a customer will just create an extra large warehouse because they're like, I got to do a lot of work. That's not how it works. So if you have high data intensity, really complex queries and your warehouse is spilling, increase the size of the warehouse. If you have lots of queries to burn through, increase concurrency. Do not increase the size. It does not help you in most cases. Very, very good. All right. So what happens if the warehouse, and this shows sort of the disk spilling and data intensity, similar to the summary metrics we showed above. Basically, if it's red, it's spilling to disk, which means it's not enough memory. If it's green, it's not. So very, very simply, if you see mostly green here, your warehouse is good. It's either too big or perfectly sized for your workload. And you can then see your data intensity. So your P99 of data reads is 1 gigabyte, but there is maybe 1 or 2 queries that read 100 gigs. So that matters. So that's the sort of trade-off you want to see and the distributions you want to highlight. And you can even break that out by warehouse. So we can see this warehouse had that 100 gigabyte query. So maybe we should split out the workloads to make sure that maybe we have a higher concurrency configuration here, and maybe we make this one a little bit bigger t-shirt size wise, but we don't increase the concurrency. So, making the decision between splitting and combining workloads on a warehouse is also really important as well. And that's going to matter based on concurrency needs and data intensity needs. The best way I can describe deciding when to split versus when to combine workloads is just the heterogeneity of the workloads. So if they look and feel very different, if you have a BI workload that's really high concurrency, lots of small queries, running on the same warehouse as an ETL workload that's not concurrent, it has no concurrent queries, but has really, really beefy pipelines, you probably want to split the warehouse because you don't want the t-shirt size to be, sized for your most intense ETL pipeline, but the currency to be sized for your most intense concurrency scaling. Your lowest common denominator is high in both scenarios. So that's a good example of when to split versus when to combine. And that's really it. So those are the metrics we have to size. And then, then the remaining question comes, if my warehouse is sized pretty well, and things are still not going perfectly, or maybe they're going well for a while, but my warehouse is getting worse over time, something's going wrong. This query performance detail section helps you actually find bad queries and figure them out and root cause analysis them very, very quickly. So there's only a fixed number of reasons why queries are bad. They take too long to run, they spill to disk, they read and write too much data, they queued too much, or they errored out. And that's about it. So we codified those into flags, into basically just red-green bars. So all you have to do here is click on the red bars, click on the long-running queries, click on the data-intensive queries, and then you get your problem queries. And these are your individual queries themselves. These show you the specific, query ID, the link to specific dashboards or SQL queries that drove it, as well as the actual people and statements that ran on what happened, and all the metrics associated with that. So in a couple clicks, we're able to then further refine the weakest parts of our query profiles and our query runtimes here. So we can do top-down sizing of our warehouses, so we don't have to do this needle in the haystack exercise from the beginning. That's what a lot of customers do. They will try to optimize a warehouse by tuning one query at a time, and they're just forever in that loop of doing that. But here, we size our warehouses from a top-down perspective with warehouse level metrics, and then we can dig into the needles that we have remaining to solve. So that's really the dashboard. I hope this helps sort of structure how you walk through this to get value out of it. And any other questions or thoughts on the dashboard?
No, I love it. It's just perfect, and that's for the folks who are watching us. If you want to add an additional metrics, you can just go and edit the dashboard and add your custom metrics. The code try to think about everything like generic, but you can add your own if you want. But I think like honest is super useful, and you thought about almost everything. I don't see anything else we can add, or maybe wait if we have additional system tables that can give us more information that can be leveraged too.
Yeah, and I'll try to be the first one to incorporate the new features as they come out, so that this dashboard is as up to date as possible. And then one last thing that is a really common ask is like query tagging. So if users have a lot of workloads on the warehouse, let's say they're DBT jobs or their actual application jobs that run, you can actually custom create a signature, like a templated custom comment, and put that in the actual data model of this. And then it'll pull that up and parse that. So for example, by default, this dashboard understands all the DBT metadata. So if you're running DBT jobs on your warehouse, you can actually find, there's no DBT workloads on this warehouse, but it automatically parses the DBT metadata like target, profile, as well as the individual node ID models themselves. So you can gauge performance of specific subsets of DBT jobs. And then, if you want to customize the actual tagging of the metadata, you can do that yourself and create your own templated comment to categorize queries into. It's very, very common ask. So that framework is embedded into the dashboard and in the data model itself.
Perfect. Thank you, Cody. Thank you so much. And we'll talk soon about another dashboard if I'm not wrong.
All right. That sounds good.